We'll try to understand the shape ellipse. Right. An ellipse is a set of all the points in a plane, the sum of whose distance from two fixed points in a plane is constant. So if I take 2 point S1 and S2, and I take some point P1 whose distance from S1 and S2 is constant. If I take another point P2, then the distance from this point from this will be the same. If I take point 3, then the distance, sum of distance, that is S1 P1 plus S2 P2, will be same as S1 P2 S2 P2, and it will be same, that is S1 P3 plus S2 P3. So if I connect these all points, then the figure obtained will be somewhat like an oblong circle, which is called as ellipse, right? So this is how we obtain or we get the shape ellipse. Here the two fixed point are the foci. You can see that we have two focus, therefore here the two fixed points are called foci, and the exactly midpoint of this is called the center of the ellipse. So if I take the midpoint of these 2 points, then I will get the center of the ellipse. See, we'll try to understand this shape using eccentricity. Uh, let's take one fixed line and a fixed point. Then it is a set of all points uh, whose distance from the fixed point to the perpendicular distance from this line, let's say SP divided by PM, will always be same. If I take another point, say P1, then the distance of this point from the focus to the perpendicular distance with this fixed line will always be same. If I join this point, then the figure obtained will be ellipse, right? But the ratio here uh, obtained is called eccentricity E. So we will use this E to find the focus and directrix and all. Here the fixed point is focus, whereas this fixed line is the directrix. As you have seen earlier, that parabola also have directrix. Here ellipse will have two directrix, as you are having just one directrix in case of parabola. So if you are interested in finding eccentricity, then there are multiple ways to find it. One of the way is taking the ratio of the distance of the point from the focus to the perpendicular distance from the line. This will give you eccentricity. Now we have two types of ellipse. One is having its major axis along x-axis, and one of the type it's having its major axis along y-axis. So how you will get that the given ellipse is having its major axis as x-axis or its major axis as y-axis? Using the standard equation we can understand. So see, this is the standard equation of ellipse: x square by a square plus y square by b square is equal to 1. But here in this case, your a square will be greater than b square. So we'll understand that here the major axis is x-axis, and the standard equation for this type of ellipse is also a square x square by a square plus y square by b square is equal to 1. But here in this case, your b square will be greater than a square. Then you will understand that the major axis in this case is y-axis, right? So if you are interested in finding the eccentricity, then you can apply formula: b square is equal to a square 1 minus e square. Here the eccentricity is less than 1. And if you are interested in finding the eccentricity, then here you can apply the formula: a square is equal to b square 1 minus e square. Right. Then foci, here it will be on x-axis, it will be plus minus a comma 0. This is your foci: a comma 0 minus a comma 0. Vertex, whenever vertex is written, we will consider the vertex of major axis only, but the vertex of minor axis can also be uh, found out, and that will be 0 comma b and 0 comma minus b. So here I am not writing, but if you want the vertex of minor axis, then it will be on 0 comma plus minus. The same way here, the foci will be on y axis, and it will be 0 comma plus minus be. So this is these are the foci. The here the vertex, that is vertex of major axis, is 0 comma plus minus b. If you are interested in getting the or knowing the vertex of minor axis, then it will be a comma 0 and minus a comma 0. Right. Then the length of latus rectum. Now here in this case, the latus rectum is a line segment that is passing through the focus and exactly perpendicular to major axis. Here you will get two latus rectum. In both the case, you will have the same length, that is 2b square by a. Here the length of latus rectum will be 2a square by b. Here also we will get 2 latus rectum. Now, equation of directrix. You will have two directrix over here. It will be x is equal to plus minus a by e. This will be x is equal to a by e, and this is x is equal to minus a by e, whereas here the equation of directrix is y is equal to plus minus b by e. One will be over here and one will be over here. This is y is equal to minus b by e, whereas this is y is equal to plus b by e. You will have two directrix. Right. See, they will also ask you to find the length of major axis and length of minor axis in both the case. So we'll rub some portion of this and we'll write the length of. See, here no one will tell you that the given ellipse is having a major axis as x-axis or y-axis. You only have to decide it by just carefully seeing the values of a square and b square. If your value of a square is greater than b square, then the major axis is x-axis, whereas the value of b square is greater than a square, then your major axis is y-axis. Meanwhile, here the eccentricity, the value of eccentricity will be less than 1, whereas in case of hyperbola, the value of eccentricity will be greater than 1. So I am just rubbing this equation of that is standard equation of ellipse, and I will write two formula pertaining to the length of major axis. See, length of major axis is the distance between these two vertices, that is from A to A dash, and here this is your center of ellipse, which is origin. We can see that the distance from origin to vertex A is also A, and from the origin to A dash is also A. So the length of major axis will be 2A, whereas the length of minor axis will be 2B, and in this case the length of major axis will be 2B, and the length of minor axis will be 2A. Exercise 11.3, first question. The given equation of ellipse is x square by 36 plus y square by 16 is equal to 1. You can see that the value of a square is greater than the value of b square. Therefore, here the major axis is x-axis. So we will use the formula pertaining to major axis as x-axis. So on comparing, I will get a square as 36. On comparing with who? X square by a square plus y square by b square is equal to 1. I will get a square as 36, b square as 16, and that is a is 6 and b is 4. Here a square is equal to b square, 1 minus e square will be used to find the value of eccentricity. So 16 is equal to 36, 1 minus e square. So 16 by 36 is equal to 1 minus e square. E square is equal to 1 plus 16 by 36. This will give you 12, 4, 5. Therefore, e square is equal to 1, 4 ones are 4, and 3s are 12, and 9s are. So e is square root 13 by 3, right? So we got the value of eccentricity. Now coordinates of foci is plus minus a comma 0, plus minus value of a 6, eccentricity is root 13 by 3 comma 0. So plus minus 2 root 30 comma 0, and vertex is plus minus a comma 0, length of major axis 2a, 2 into 6, 12, length of minor axis 2b, 2 into 4, 8, eccentricity we got, and finally the length of latus rectum, which is 2b square by a. 4 upon a is 6, 2 ones are 2, 3s are, so it is 4 by 3. We did one mistake over here. You can understand that this will be minus over here. Taking plus 16 by 36, it will be minus. So 16 minus 20. So this will be uh, 20 by 36, and this will be root 20 by 6. So here it will be root 20 by 6, and this 6 and 6 will get cancelled out, and I will have my foci as plus minus root 20 by 0. Rest all is correct. And here also we did one mistake. That is, we have to take the value of a, but we took the value of a square. Here the value of a is 6. So, and sorry, value of b square is 16 and not the 4. 4 is the value of b. So we have to keep the value of b square. So here it will be 16 by 6. The value will be 16 by 3 and not 4 by 3. We did a mistake in keeping the value of b square. Here I kept 4, but it should be 16. As you can see that the value of b square is 16. So 2 into 16 by a, that is 6. And we reflected these two ones are 2, 3s are, and the final value of length of LR will be 16 by 3. So you have to be careful while placing these values. You can see that this might get interchanged and will get the incorrect answer. Question 2. Here the given equation of ellipse is x square by 4 plus y square by 25 is equal to 1. Here you can see that the value of b square is greater than the value of a square. Here major axis is along y axis. So on comparing with x square by a square plus y square by b square is equal to 1, I have a square as 4 and b square as 25. Therefore the value of a is 2 and b is 5. Here I will apply a square is equal to b square 1 minus e square. So 4 is equal to 25 1 minus e square. So 4 by 25 is equal to 1 minus e square. E square will be 1 minus 4 by 25. Therefore e square is 21 by 25. So your e will be square root 21 by 5. The coordinates of foci will be on y-axis 0 comma plus minus be. Value of b is 5. Eccentricity is root 21 by 5. 5 will get cancelled out and my foci are 0 comma 20 root 21. And then vertices, you know that we are asked to write vertices of major axis, which is 0 comma plus minus b. Here the value of b is 5. So vertices is the length of major axis. The length of major axis is 2b, 2 into 5 it is 10, whereas the length of minor axis is 2a, that is 2 into 2, it will be 4. And lastly the length of latus rectum is 2a square by b. So 2 into the value of a square is 4, whereas the value of b is 5. So it will be 8 by 5.